What if I told you the gods of Olympus didn't just live in temples or thunder from the sky, but hid in plain sight, woven into the very fabric of numbers? Picture this. Ancient mathematicians didn't just crunch numbers, they communed with them, believing each digit held the essence of a deity, each equation a hymn to the divine. From the sacred triangles of Pythagoras, whispered to be gifts from Apollo, to the way the number 3 echoed the trinity of Zeus, Poseidon, and Hades, math wasn't cold calculation, it was a celestial love letter. This is the story of how algebra didn't just solve problems, it spoke in riddles of gods and heroes, turning myths into formulas and legends into logic. Think about the number 12 for a moment. It's not just a tally on a page, it's the 12 Olympians gazing down from the heavens, the 12 labors of Hercules carved into numerical code. The ancients saw patterns everywhere, the spiral of a seashell mirroring the whirl of Poseidon's trident, the golden ratio shaping Aphrodite's face. They didn't separate math and myth, they bound them together, believing that to solve an equation was to decode the will of the universe. Why did Pythagoras sacrifice 100 oxen when he discovered his famous theorem? Because to him, it wasn't just a proof, it was a revelation, a glimpse into the mind of the gods. So how did this sacred connection fade? How did numbers lose their divinity, reduced to dry symbols on a chalkboard? That's the mystery we're unraveling today. We'll trace the hidden threads between Euclid's geometry and Athena's wisdom, between algebraic unknowns and the oracle's cryptic whispers. You'll never look at a math textbook the same way again, because behind every formula, there's a story waiting to be told, a god waiting to be remembered. This isn't just history, it's a rediscovery of magic where every calculation is an incantation and every solution a step closer to Olympus. The ancient world didn't just count with numbers, they communed with them. To the Babylonians, the number 60 wasn't merely a base for their numeral system. It was the heartbeat of the heavens, a sacred echo of the 60 gods who governed the cosmos. Each digit pulsed with celestial energy. The number 3 belonged to Ishtar, goddess of love and war, while 12 mirrored the 12 zodiac signs, a divine clockwork guiding human destiny. Even their star charts doubled as mathematical tablets, where solving an equation meant deciphering the gods' whispers. Cross the desert to Egypt, and you'd find the pyramids standing as silent hymns to sacred geometry. The slope of their sides wasn't arbitrary, it followed the Sikht, a ratio believed to mirror Ra's journey across the sky. Builders didn't measure stone, they measured divinity, ensuring every angle aligned with cosmic law. When the Nile flooded, priests didn't just calculate the water's rise, they interpreted it, seeing the number 4 in the river's 4 sacred directions, each a path guarded by a different deity. Mathematics wasn't a tool, it was a temple, and every calculation a prayer. But perhaps no one revered numbers more deeply than the Pythagoreans. To them, digits were living spirits, odd numbers masculine, even numbers feminine, each with its own personality. The number 1 was the monad, the seed of creation, while 4 symbolized justice, solid as earth. They'd whisper secrets of the tetractys, a pyramid of 10 dots that held the universe's blueprint, its layers echoing the harmony of Apollo's lyre. When Pythagoras declared, "All is number," he didn't mean it metaphorically. He meant the gods themselves were equations, their wills written in geometry's invisible ink. This wasn't superstition, it was a language. Just as myths used stories to explain storms and seasons, numbers became another dialect of the divine. A Babylonian trader tracking the moon's phases wasn't just avoiding a shipwreck, he was reading Sin, the moon god's ledger. A Greek architect drawing a pentagon wasn't just designing a floor plan, he was tracing Aphrodite's sacred symbol. The line between algebra and altar didn't exist. To solve for X was to seek a god's hidden name, and every proof unveiled a fragment of eternity. So when Euclid penned his Elements, he wasn't just writing a math textbook, he was compiling a scripture. His proofs weren't cold logic, they were incantations, each step a ritual to reveal the order the gods had woven into chaos. The ancients didn't separate the rational from the mystical because to them, numbers were the mystical. And buried in today's equations, those divine whispers still linger, if you know how to listen. Pythagoras didn't just see numbers, he heard them. To him, the universe hummed with hidden harmonies, a symphony of ratios and resonances where planets moved in perfect intervals, their orbits vibrating like the strings of Apollo's lyre. This wasn't poetry, it was physics, a sacred geometry where the distance between Earth and the stars corresponded to musical notes. The harmony of the spheres wasn't a metaphor, it was a cosmic truth, proof that the gods composed reality in fractions and frequencies. His followers didn't just study math, they worshipped it. The Pythagoreans gathered in secret, swearing oaths over the tetractys, a triangular figure of 10 dots that held the secrets of creation. Each layer of the pyramid whispered a different divine truth. The monad at its peak represented unity, the source of all things, while the base, the number 4, embodied the elements earth, air, fire, water, each governed by its own deity. To solve an equation was to commune with these forces, to align human thought with celestial order. Odd and even numbers weren't just classifications, they were living spirits. The number 3, jagged and dynamic, channeled the energy of Zeus, king of the gods, while the gentle curve of 2 mirrored heroes nurturing grace. The Pythagoreans refused to eat beans, not out of superstition, but because the legume's hollow stems resembled the underworld's gates, their shape a geometric omen. Even their daily rituals were calculations, stepping over thresholds in specific counts, arranging pebbles in sacred patterns, all to keep the numerical balance of the cosmos intact. But Pythagoras' greatest revelation, the theorem that bears his name, was more than a tool for measuring triangles. When he discovered that the squares of a right triangle's sides danced in perfect equilibrium, he didn't just celebrate, he sacrificed 100 oxen to the muses. To him, the theorem was a divine signature, proof that the gods had etched their logic into the fabric of space. The hypotenuse wasn't just a line, it was a bridge between mortal minds and immortal order, a path to revelation. Yet for all its beauty, this vision had a dark side. The Pythagoreans guarded their knowledge fiercely, drowning a member who leaked the scandalous truth that irrational numbers existed, numbers that couldn't be expressed as fractions, shattering their dream of a perfectly ordered universe. Even the gods, it seemed, had left mysteries unsolved, but that tension between the clean lines of theory and the messy edges of reality only deepened the allure. To Pythagoras, math wasn't just a language for describing the world. It was the world, a living, breathing testament to the divine, and in that truth he found not just answers but awe. The golden ratio wasn't just a number, it was Apollo's signature, etched into the veins of leaves and the sweep of galaxies. Imagine standing before the Parthenon, its columns rising not by chance but by sacred geometry. Every curve, every spacing follows the ratio of 1.618, a proportion so precise it makes the marble seem to breathe. The architects didn't just build, they invoked, aligning their designs with what the Greeks called the divine proportion, a harmony so perfect it could only belong to the gods. Take a sunflower spiral, each seed placed at an exact angle to the next, unfolding in a rhythm that mirrors the ratio. or gaze at a nautilus shell, its chambers expanding in the same flawless pattern. The Greeks saw these shapes and didn't call it biology, they called it Apollo, god of light and order, whispering his logic into the fabric of life. Even the human body bowed to this rule. Da Vinci's Vitruvian Man, with his outstretched limbs, fits inside both a circle and a square, his navel dividing his height by none other than the golden ratio. But why did this number feel so alive? Because to the ancients, beauty wasn't subjective, it was mathematical. Temples built with the ratio didn't just please the eye, they resonated with the soul, as if the stones themselves were humming Apollo's hymn. The Parthenon's facade, the curve of a lyre's neck, even the spacing of stars in the Milky Way, all followed this cosmic blueprint. It wasn't just aesthetics, it was worship, a way to touch the divine through line and form. And the magic wasn't lost on later thinkers. Renaissance artists like Botticelli painted Venus rising from the waves, her proportions a deliberate echo of the ratio, while composers like Debussy structured symphonies around its intervals. The ratio wasn't just a tool, it was a bridge between the mundane and the mystical, a secret handshake between human creativity and the god's design. Yet here's the wonder, the ratio wasn't invented. It was discovered, uncovered like a relic buried in the soil of the universe. Whether in the twist of DNA or the arch of an eyebrow, the pattern persisted, proof that Apollo's code wasn't just art or architecture. It was the pulse of existence itself, a number that didn't calculate but consecrated. To wield it was to hold a fragment of the divine, to build not just with stone but with stars. Plato didn't just teach philosophy, he sculpted souls with geometry. In his dialogue Timaeus, he made a startling claim. The human soul wasn't some shapeless spirit, but a living, breathing triangle. Philosophers, he declared, possessed the sharpest angles, their minds like pristine equilateral triangles, balanced and eternal. Warriors, meanwhile, carried the sturdiness of squares, their souls built for resilience. Even artisans had their form, their souls bending like polygons, adaptable yet grounded. This wasn't metaphor. To Plato, the soul's shape dictated its destiny, a cosmic law written in lines and vertices. Picture the universe as Plato saw it, not a void but a glittering polyhedron, each face a different element. Fire was a tetrahedron, its sharp points cutting through chaos. Earth was a cube, steady and unyielding. Air and water took the forms of the octahedron and icosahedron, their fluid edges mirroring the breath of the gods. And enclosing it all, the dodecahedron, 12 pentagons symbolizing the heavens themselves, a cage of divine geometry. These weren't just shapes, they were the building blocks of reality, the gods' fingerprints pressed into the fabric of existence. But why triangles for souls? Because to Plato, purity wasn't just a virtue, it was a measurement. The equilateral triangle, with its equal sides and perfect symmetry, reflected the philosopher's pursuit of truth, its angles untainted by imbalance. A distorted triangle, uneven and jagged, signaled a soul weighed down by ignorance or vice. Even the act of learning was geometric. Knowledge sharpened the mind's angles, polishing the soul until it could refract wisdom like light through a prism. The stakes were higher than scholarship. Plato believed that after death, souls were judged by their geometry. A philosopher's triangular soul might ascend to the stars, merging with the celestial polygons of the cosmos. A warrior's square soul could be reborn, its sturdy edges suited for another life of struggle. But a soul too misshapen by wrongdoing, it might crumble like a flawed pyramid, its fragments scattered into chaos. Mathematics wasn't just a study, it was salvation, a path to align with the divine blueprint. This vision bled into art and science for centuries. Renaissance architects designed cathedrals with Platonic solids in mind, believing their proportions could elevate worshippers' souls. Kepler, centuries later, plotted the planets' orbits based on these same shapes, convinced the universe moved to geometric music. Even today, the allure persists. Modern physicists find echoes of Plato's solids in the symmetries of quarks and the structure of crystals. The line between math and myth may have blurred, but the question remains: what if Plato was right? What if the soul's true shape isn't a mystery, but a calculation waiting to be solved? Euclid's Elements didn't just teach geometry, it mapped a cosmos where lines and angles held the weight of myth. Think of it as the Odyssey of mathematics, a 13-volume epic where every proof was a trial to overcome, and every axiom a divine decree. Take his infamous fifth postulate, the one about parallel lines never meeting. It wasn't just a rule, it was a riddle, a Sphinx's challenge that tormented scholars for centuries. Some called it the divine law, others a trick of the gods, sparking debates as heated as the clashes between Athena and Ares. Why? Because Euclid wasn't just writing a textbook, he was drafting a scripture where geometry's unshakable truths mirrored the immutable will of Olympus. Consider the way he structured his proofs, each step a hero's journey. You start with the given, like a warrior handed a quest. Then come the constructions, the tools and tricks, your sword and shield. Next, the deductions, battles fought with logic, until finally, QED, the triumphant return home. It's no accident that medieval monks copied Elements alongside religious texts, treating its pages like sacred scrolls. To them, Euclid's proofs weren't just correct, they were holy, a glimpse into the mind of a universe ruled by geometric gods, and what gods they were. The circle, perfect and endless, belonged to Apollo, symbolizing the sun's eternal cycle. The triangle, with its three faces, echoed the fates Clotho, Lachesis, and Atropos, weaving destiny with angles instead of thread. Even the dodecahedron, Plato's shape of the heavens, found its way into Euclid's work, a 12-sided altar to the cosmic order. Geometry wasn't just a science, it was a pantheon, and Euclid, its high priest, revealing the gods' blueprints one proposition at a time. But here's the twist: Euclid's fifth postulate hid a secret. For 2,000 years, mathematicians tried to prove it from the other axioms, as if testing Zeus's patience. Then, in the 19th century, rebels like Lobachevsky and Gauss dared to ask, what if it's not true? They bent the parallel lines, warping space into hyperbolic realms where triangles defied Euclid's rules. It was as shocking as mortals challenging the gods, and just as transformative. Suddenly, geometry wasn't a single divine law, but a multiverse of possibilities, each with its own logic. Yet even in rebellion, the mythic heart remained. Modern physicists still speak of Euclidean space as the default, the Olympus from which other geometries descend. And those who master Elements today don't just learn proofs, they inherit a legacy, stepping into the same heroic role as Pythagoras or Hypatia, wrestling with shapes that once bore the names of gods. Euclid's work endures because it's more than math. It's a saga written in the language of the universe, where every line is a legend and every proof a pilgrimage. Archimedes didn't just solve equations, he weaponized them. When Roman warships darkened the horizon of Syracuse, the city didn't turn to its generals or gods for salvation. They turned to a mathematician, a man who wielded geometry like Poseidon's trident. His claw, a monstrous crane hidden along the seawall, would reach down, hook enemy ships, and hurl them into the sky before smashing them against the rocks. The Romans didn't fear Greek soldiers, they feared the whispers that Archimedes had forged a pact with Hephaestus, bending the laws of physics to his will. How else could a single man, armed only with a compass and his mind, hold an empire at bay? Then there were the mirrors. Legends say he lined the shore with polished bronze, angling them to focus sunlight into a searing beam that set Roman sails ablaze. Scholars still debate if it was possible, but the story stuck not because it was proven, but because it felt true. Here was a mortal who didn't just study the cosmos. He harnessed it, turning Apollo's own light into a weapon. The Romans didn't see a scientist, they saw a sorcerer, a heretic who'd stolen fire from the gods a second time. But Archimedes' greatest rebellion wasn't on the battlefield. It was in his scrolls. In the sand reckoner, he did the unthinkable. He calculated the number of grains of sand that could fill the universe. To the Greeks, infinity belonged to Zeus alone, a concept too vast for mortal mind. Yet Archimedes penned a number so large it would take 1,000 lifetimes just to speak it aloud. This wasn't just math, it was blasphemy, a declaration that human reason could measure the immeasurable, that the gods' domain wasn't beyond reach after all. And then the final act. When Roman soldiers finally breached Syracuse, they found an old man kneeling in the dirt, tracing circles in the sand. Ordered to stand, he snapped, "Do not disturb my circles." And a sword cut him down. Historians call it a tragic accident, but the mythmakers knew better. This was Icarus falling from the sky, Prometheus bound to the rock. A man who dared to think like a god, struck down for his arrogance. Even in death, his legend grew. They buried him beneath a tomb carved with a sphere inside a cylinder, the solution to his favorite proof. A monument not to a mortal, but to the mind that had touched the divine and paid the price. 2,000 years later, we still whisper his name with a mix of awe and unease. Because Archimedes wasn't just a genius, he was a warning and a promise, a warning that the gods tolerate no rivals, a promise that numbers wielded boldly can shake the heavens themselves. Zero wasn't just a placeholder, it was a revolution, a mathematical leap as daring as stealing fire from the gods. Ancient India's mathematicians didn't invent it out of necessity, they birthed it from myth, calling it shunya, the void. But this wasn't emptiness, it was the cosmic womb, the silence between notes where creation hummed. Picture the Rigveda's hymns where the universe emerges from nothingness, as if zero had always been there, waiting in the dark like a coiled serpent. The Babylonians and Greeks had danced around the concept, fearing the void's chaos. But India embraced it, seeing in zero the same potential as Vishnu dreaming worlds into being on the ocean of non-existence. Now cross the ocean to the Maya, where zero wasn't a beginning, it was an ending and a beginning again. Their long count calendar didn't just track time, it pulsed with it, zero marking the day the world reset, when the sun god Kinish Ahau plunged into the underworld before rising reborn. The shape of their zero wasn't a circle, but a shell, a spiral, a doorway. To count from zero wasn't just arithmetic, it was ritual, a miniature apocalypse and Genesis with every tally. But why did zero terrify the West for centuries? Because to the Greeks, zero wasn't holy, it was heresy. Aristotle declared nature abhorred a vacuum, and Pythagoreans saw the void as a crack in their perfect numerical universe. When Indian numerals reached Baghdad, scholars like Al-Khwarizmi called zero cipher, meaning empty, but even Islam's golden age treated it with suspicion. The church later banned it, fearing a symbol that could make something from nothing, like a mortal playing God. Yet zero's power couldn't be contained. Without it, there's no calculus, no physics, no digital age, just as without chaos, there's no creation myth. Modern physics whispers of zero-point energy, the universe's hum from the void, echoing those ancient visions. The irony, today, zero is everywhere. encode in equations in the silent space between heartbeats, yet we've forgotten its divinity. It's time to remember, every time we write 0, we're not just noting absence. We're invoking the oldest magic of all, the moment before the gods said, "Let there be light." Long before X and Y became cold symbols on a page, they pulsed with the heartbeat of the gods. In the dusty archives of Babylon, mathematicians didn't solve equations, they decoded the whispers of Ishtar, goddess of love and war, whose celestial dance as the planet Venus dictated fate itself. Their clay tablets, etched in cuneiform, reveal quadratic equations not as abstract puzzles, but as sacred scripts, each solution a prophecy, each variable a celestial omen. Take tablet YBC 4684, where a scribe calculates the area of a field, only to reveal the answer corresponds to Venus's rising. This wasn't coincidence, it was covenant. The Babylonians saw numbers as threads in Ishtar's tapestry, weaving together harvests and battles, weddings and wars. When they solved for X, they weren't finding an unknown, they were unmasking the goddess's next move. A quadratic equation predicting crop yields, also a harbinger of her favor or wrath. The famous Plimpton 322 tablet, with its Pythagorean triples, wasn't just math homework, it was a star map, aligning earthly geometry with the divine. Their methods were as poetic as they were precise. To solve quadratics, Babylonian scholars used steps eerily similar to our modern, completing the square, but with a twist. Each manipulation mirrored rituals from Ishtar's temples. Division by 2 wasn't just arithmetic, it echoed the splitting of the heavens into day and night, her dual domains as both lover and warrior. The moment of solving wasn't called finding the root, but unveiling the door, as if the answer swung open a gateway to the divine. And the stakes are life and death. A miscalculation in predicting Venus's movements could mean misreading Ishtar's mood, risking failed marriages or lost battles. Kings demanded these calculations before launching campaigns, trusting algebra more than scouts. When the scribes wrote problems about dividing grain stores, they weren't teaching math, they were training priests to hear the gods in every harvest, every battle, every rising star. Yet here's the twist. Babylon's algebra vanished for millennia, dismissed as primitive until modern archaeologists cracked its code. Today, we teach quadratics stripped of their celestial magic, reducing Ishtar's star equations to sterile formulas. But the old clay still whispers, reminding us that every time we solve for X, we're not just crunching numbers. We're walking a path first carved by those who dared to read the universe as both equation and epic, where every variable was a verse in the gods' eternal hymn. The Fibonacci sequence unfolds like Dionysus himself, wild, untamed, and drunk on creation. Picture this: 1, 1, 2, 3, 5, 8, spiraling outward in an endless dance, each number the sum of the two before it. At first glance, it's just a neat mathematical trick, but look closer and you'll find it coiled in the tendrils of grapevines, the very plants Dionysus, god of wine and ecstasy, claimed as his own. The sequence doesn't just grow, it revels, twisting through nature with the same abandon as the god's drunken followers, leaving a trail of numerical intoxication in its wake. Take the Nymphaea, the water lily sacred to Dionysus. Its petals unfold in Fibonacci counts 3, 5, even 13, each layer a drunken whisper of the sequence. Art historians once thought ancient vase painters just liked the way these flowers looked. But what if they were encoding a secret? The same spiral appears in the god's own iconography, his Theseus staff crowned with a pine cone, its scales arranged in perfect Fibonacci rows. Coincidence? Hardly. To the Greeks, this wasn't just a pattern. It was proof that Dionysus wove math into madness, that even chaos had its divine rhythm. And then there's the grapevine, prune a shoot and new branches sprout in Fibonacci pairs, as if the plant itself is counting its way toward the next harvest. Medieval monks tending vineyards noticed it first, calling it God's numbering, but the truth was older, wilder. Dionysus wasn't just the god of wine, he was the god of transformation, of life force erupting through cracks in the rational world. His sequence didn't just add, it multiplied, exploded, a numerical echo of vines bursting from soil, of grapes fermenting into wine, of souls unraveling into ecstasy. Here's the kicker: Fibonacci didn't invent his famous sequence. He stole it from the Arabs, who stole it from the Indians, who likely absorbed it from nature's own scrolls. But the Greeks, they'd already glimpsed its magic. In the myth of Dionysus's birth, Zeus sews the infant god into his thigh, a numerical pun, since thigh miros sounded like part miros, hinting at division, at fractions, at the infinite splitting that defines the sequence. Even his rebirth mirrored it, torn apart by titans, then reborn, each fragment a new beginning, just as 5 splits into 3 and 2, which split again and again endlessly. So when Renaissance artists like Botticelli painted Dionysus with vines curling in golden ratios, they weren't just decorating, they were confessing an ancient truth: math isn't sterile. It's drunk, it stumbles through the universe, spilling numbers like wine, leaving spirals in sunflowers and galaxies in its wake. The Fibonacci sequence isn't a cold calculation, it's Dionysus's laughter, ringing from the stars to the soil, a toast to the divine madness hiding in every leaf, every petal, every pulse of life. Cheers to that! Astrolabes weren't just tools, they were Athena's mechanical owls, their brass wings etched with the secrets of the cosmos. Picture a medieval scholar under a crescent moon, turning the device's delicate dials as if consulting the goddess of wisdom herself. Each curve on its face, every parabola, hyperbola, and ellipse was a conic section, the same shapes Apollo traced with his lyre when he charted the stars. To hold an astrolabe was to hold a piece of the divine, a handheld cosmos where math and myth spun together like constellations. The Persians called it the mirror of wisdom, a name that would have made Athena smile. Its retere, a lacework of star pointers, mimicked the celestial sphere, while its plates, engraved with concentric circles, mapped the Earth's latitudes like Minerva's own battle plans. Muslim astronomers like Al-Biruni didn't just use astrolabes to find Mecca's direction, they saw them as oracles, their rotating discs revealing the will of the heavens as clearly as Delphi's priestess. Navigators whispered prayers to Polaris as they aligned the Alidade, trusting the device to guide them across trackless seas with the same certainty Athena guided Odysseus home. But here's the magic: astrolabes didn't just calculate, they conversed. To solve for a star's altitude, you'd slide the retere until its markings aligned with the horizon, a dance of brass and intuition. The device demanded both precision and poetry, blending Euclid's geometry with the stargazer's instinct. No wonder medieval monks compared its moving parts to the wings of Athena's owl, a creature that saw through darkness with uncanny clarity. The astrolabe's curves weren't arbitrary, they were sacred, echoing Apollo's conic sections, the very shapes he used to harmonize the spheres, and the myths didn't stop at its design. Persian legends claimed the first astrolabe fell from the heavens, a gift from the angel Jibril. Greek texts hinted that Archimedes had forged a prototype under Athena's guidance, its gears mimicking the orbits of her sacred bird. Even the act of reading one felt like deciphering divine code. The shadow of the Alidade became a sundial by day, a compass by night, its needle trembling between myth and measurement. Today, we've traded astrolabes for satellites, but something vital was lost in that leap. Modern GPS gives coordinates, but the astrolabe gave meaning, turning cold coordinates into constellations with stories. To plot a course with one wasn't just navigation, it was negotiation, a mortal reaching into the sky to ask the gods for direction. The next time you glance at your phone's map, remember, beneath its glass screen beats the heart of an ancient owl, still longing to whisper Athena's wisdom in your ear. Al-Khwarizmi didn't just write a math book, he penned a grimoire. His compendious book on calculation by completion and balancing sounds like an incantation because in many ways it was. The word algebra itself comes from his term al-jabr, meaning the reunion of broken parts, a phrase Persian physicians used to describe setting bones. To him, solving an equation wasn't just logic, it was surgery, a sacred act of restoring balance to a fractured world. Imagine a 9th century scholar in Baghdad's House of Wisdom, dipping his quill not in ink, but in the same cosmic ink the gods used to write the stars. His genius wasn't in inventing algebra, it was in revealing its hidden language. Before Al-Khwarizmi, math was a scattered collection of tricks like fragments of a shattered mirror. He pieced them together, showing how to move terms across the equals sign like alchemical ingredients, transforming leaden problems into golden solutions. The ancients had whispered of equations, but he gave them grammar, turning chaos into verse. Even his title, Completion and Balancing, echoed Zoroastrian dualism, the eternal struggle between light and dark, order and chaos now tamed on a parchment. But here's the twist, Al-Khwarizmi didn't use modern symbols. His equations were spelled out in flowing Arabic script, verbs instead of variables. A thing multiplied by itself equals 5 times the thing, no x's or y's, just poetry. To solve them felt less like calculation and more like decoding a jinn's riddle. When he described completing the square, he didn't just mean geometrically, he meant cosmically, as if each equation was a miniature universe begging to be made whole. And the world noticed. Medieval Europe, still clinging to Roman numerals, translated his work as Dixit Algoritmi. Thus spoke Al-Khwarizmi, turning his name into algorithm, the foundation of digital magic today. His bone-setting metaphor stuck too. Spanish barbers hung signs reading Algebrista, advertising both math tutoring and wound healing, because in the end, that's what algebra was, a balm for the mind, stitching together broken logic with the needle of reason. Yet beneath the numbers lurked the old gods. Persian myths spoke of Jamshid's cup, a divination tool that revealed cosmic truths, a precursor to Al-Khwarizmi's equations, both vessels of hidden knowledge. Even his quadratic solutions mirrored the dualities of Ahura Mazda and Angra Mainyu, light and dark roots emerging from a single problem. So next time you solve for X, remember, you're not just doing math. You're speaking a spell, one that once made caliphs gasp and scribes tremble, a whisper from the golden age when numbers didn't just compute, they conjured. Pi wasn't just a number to the ancients, it was a labyrinth. Its endless decimals twisting like the corridors of King Minos's maze. The Greeks didn't calculate pi, they navigated it, using the ratio 22/7 like Theseus's thread, a mathematical lifeline guiding them through the infinite. When engineers designed the Parthenon's columns, they didn't just measure circles, they invoked Athena's wisdom, trusting that the same ratio that trapped the Minotaur could also perfect a temple's curve. Pi wasn't digits, it was destiny, a divine whisper in the language of shapes. The Egyptians went further. To them, the circle wasn't just a shape, it was the eye of Ra, unblinking and eternal. The Rhind papyrus reveals their approximation, the square of 16/9, a fraction that built pyramids aligned with celestial cycles. But here's the mystery, why did they encode pi in the Great Pyramid's very dimensions? The ratio of its perimeter to its height mirrors pi times 2, as if the architects weren't just building tombs but crafting stone equations to commune with the gods. The circle's perfection became a portal, its endless decimals a bridge between mortal minds and cosmic order. China's mathematicians saw pi through different eyes. Zhu Chongzhi in the 5th century calculated it to 7 digits, calling it the milu, the precise ratio. But this wasn't just academic rigor. In Taoist thought, the circle symbolized the Tao itself, the unbroken unity of yin and yang. Zhu's calculations weren't cold precision, they were meditation, an attempt to measure the immeasurable flow of heaven and earth. Even his tools echoed myth. The method of circle division mirrored the ancient legend of Fu Zai, who first drew the Bagua by dividing a circle into sacred trigrams. But why did pi fascinate every culture? Because the circle was the universe's first riddle, a shape with no beginning or end, yet bound by a single, elusive constant. Babylonians baked pi into their lunar calendars. Hindus tied it to the cyclical destruction and rebirth of the cosmos, and medieval monks saw its endless digits as proof of God's infinite mind. Pi wasn't just math, it was the fingerprint of whatever force shaped existence, whether gods, atoms, or cosmic laws. Today, we've computed pi to trillions of digits, yet it still defies pattern or repetition, as untamable as the Minotaur itself. Supercomputers chase its tail like modern Theseuses, but the maze remains infinite. Maybe the ancients knew something we've forgotten, that some truths aren't meant to be solved, only revered. Pi doesn't calculate it in chance, a numerical hymn to the mysteries even gods couldn't fully unravel. Negative numbers lurked in the shadows of mathematics for centuries, treated like trespassers in a realm of pure logic. Ancient Chinese and Indian mathematicians cautiously acknowledged them as debts or losses, but to the Greeks, they were as unthinkable as Hades breaking free from the underworld. How could something be less than nothing? The very idea felt like a crack in reality, a numerical heresy that threatened to unravel the orderly cosmos Pythagoras had envisioned. When Diophantus stumbled upon negative solutions in his equations, he dismissed them as absurd, as if they were phantoms whispering from beyond the veil. Then came Descartes, the philosopher who mapped the mind as neatly as he charted graphs. He banished negative numbers to the margins of his coordinate plane, allowing only positive values to roam freely in the light. To him, negatives were like rebellious spirits, useful in theory, but too dangerous to let wander unchecked. His contemporaries called them false roots or fictitious quantities, names that echoed the Greek fear of the unseen. Even as late as the 18th century, mathematicians argued whether multiplying two negatives to get a positive was divine law or dark magic. But just as Orpheus dared to descend into Hades for Eurydice, a few brave thinkers ventured into this forbidden realm. The Persian scholar Al-Khwarizmi, who had already tamed algebra, began classifying equations into 6 types, carefully separating those that might summon negatives. Centuries later, Italian gamblers like Cardano embraced them openly, using negatives to track debts in games of chance. The turning point came when Euler declared negatives not just real but essential, the dark stars of mathematics, invisible yet holding the universe together. Today, negatives are the unsung heroes of modern life. Your weather app shows sub-zero temperatures, your bank balance dips below zero, and quantum physics relies on them to describe antiparticles Hades' shadows made tangible. The very graphs that once exiled them now depend on their symmetry, their duality. What changed? Not the numbers, but our courage to face them. The underworld wasn't chaos after all. It was balance, a mirror reflecting the light above. Negative numbers didn't break mathematics. They completed it, proving that even the darkest corners of reason hold their own kind of order. Newton's calculus revealed the cold, precise equations behind planetary motion. But 2,000 years earlier, the Greeks whispered a different truth. To them, the universe didn't tick like a clock, it sang. Orpheus, the legendary musician who charmed stones and tamed beasts, wasn't just a poet. He was the first astrophysicist, his lyre strings tuned to the same celestial harmonies that bound the planets. The Greeks didn't calculate orbits, they composed them, believing each world moved to a note only the gods could hear. Picture Pythagoras crouched over a monochord, plucking a single string to study its vibrations. He noticed something astonishing. Divide the string in precise ratios, and the notes harmonize, halves create octaves, thirds make fifths, a mathematical music hidden in plain sight. Then he looked up. The planets, he realized, must follow the same rules. Mercury's swift orbit, a high, fluting note. Saturn's slow march, a bass hum resonating through the void. This wasn't metaphor, it was revelation. The cosmos wasn't silent machinery, it was Apollo's choir, a grand symphony where gravity and melody were one. Centuries later, Kepler chased the same vision. Obsessed with Pythagoras' ideas, he scribbled musical notations alongside his planetary laws, convinced Mars and Jupiter sang a celestial motet as they spun. His third law, the one linking orbital periods to distances, wasn't just a formula. It was sheet music, proving planets move in time like dancers to a cosmic score. Even Newton, the arch-rationalist, couldn't escape the allure. His law of gravitation, though framed in cold calculus, echoed the old myths. Masses attract like harmonies resonating across space, an invisible lyre strung between stars. Yet here's the twist. Modern physics is circling back to the Greeks. String theory vibrates with uncanny echoes of Orpheus's lyre, suggesting the universe's tiniest building blocks aren't particles but notes, oscillating strands of energy. The music of the spheres isn't poetry anymore. It's quantum field theory where electrons hum and quarks chirp. Even gravitational waves ripple through space-time like sound, a billion-year-old chord finally reaching our ears. So was Orpheus just a myth, or did the ancients glimpse a truth we're only now decoding with equations? The difference between Newton's math and Apollo's melodies might be thinner than we think. Both tell the same story. The universe doesn't just calculate, it performs, and somewhere in the dark between stars, a lyre still plays. The four-color theorem seems simple at first glance, just 4 shades to paint any map without neighboring regions matching. But beneath that elegance lies Athena's cunning, a mathematical spell cast across battlefields and borders. Ancient mapmakers didn't just see colors, they saw divine strategy, a way to prevent wars before they spark. Picture a Greek general unrolling a parchment, not to plan an attack but to consult geometry, trusting that the same logic that divided continents could also keep the peace. Why 4? Because Athena, goddess of wisdom and warfare, knew restraint was sharper than excess. 5 colors would have been wasteful, 3 impossible. 4 struck the perfect balance, enough to distinguish rivals, few enough to force harmony. Medieval cartographers whispered her name while inking coastlines, realizing that math could do what treaties often failed to achieve: clear, indisputable boundaries. The theorem didn't just organize space, it diffused tension, turning contested edges into neutral equations. The proof itself reads like an epic. For centuries, mathematicians chased it like heroes seeking Athena's favor, only to be tripped by hidden complexities. Then, in 1976, Appel and Haken cracked it, not with a single elegant stroke, but with a labyrinthine argument so vast it required computer aid. Purists balked. This wasn't the clean logic of Greek geometry. It was a modern oracle spitting answers even its priests didn't fully understand. Yet Athena would have approved. Victory, however messy, still counts. Today, the theorem's legacy lies in chip design, traffic routing, even pandemic modeling anywhere conflict simmers beneath the surface. It's a reminder that math isn't just about answers, but about order imposed on chaos. The next time you glance at a weather map or subway diagram, look closer. Those four colors aren't just convenient. They're Athena's oldest trick, still quietly keeping the world from unraveling. Prime numbers don't play by mortal rules, they crackle through mathematics like Zeus's thunderbolts, untamed and unbreakable. 2, 3, 5, 7, these aren't just digits. They're the universe's atomic units, the indivisible building blocks of all numbers. Try to split them and they resist, standing firm like the king of the gods himself, refusing to be divided by any lesser force. The Greeks saw something divine in their stubbornness. To them, primes weren't just tools for counting. They were sacred, fragments of celestial order scattered like lightning strikes across the numerical landscape. But here's the puzzle that's haunted mathematicians for centuries. Primes seem to follow no pattern. They appear unpredictably, vanishing and reappearing like Zeus hurling bolts from the clouds. One moment they cluster tightly like 11, 13, 17, then suddenly stretch apart, leaving vast deserts of composite numbers in their wake. Ancient scholars believed this chaos hid a deeper logic, a divine blueprint only the gods could decipher. Euclid proved primes are infinite, but how they're distributed. That mystery became math's equivalent of scaling Olympus itself. Enter Bernhard Riemann, the 19th century mathematician who dared to ask, what if primes sing? His famous hypothesis, math's unsolved holy grail, suggests that beneath their apparent randomness, primes vibrate to a hidden frequency, their positions dictated by the zeros of a function now named after him. Picture it like this: if numbers were the strings of Apollo's lyre, Riemann's zeros would be the harmonics, the silent notes that shape the melody of the primes. Solve this and you'd hold a cheat code to the cosmos, predicting primes with the precision of an oracle reading the will of Zeus. Yet the hypothesis remains unproven. Modern computers have checked billions of zeros, and so far, Riemann's intuition holds. But until someone conquers it, primes keep their secrets, as elusive as the gods who inspired them. Cryptographers already worship primes, using their unpredictability to lock away the digital world's most precious secrets. And physicists whisper that Riemann's zeros might even explain quantum chaos, bridging the gap between the tiny and the cosmic. So the next time you see a prime number, don't just count it, listen. Somewhere in its defiance, in its refusal to be broken, echoes the old thunder. The Greeks were right, primes aren't just numbers. They're the fingerprints of something greater, a reminder that even in the cold logic of math, the gods still laugh. Calculus didn't just emerge from quiet contemplation. It erupted like a divine heist, with Newton and Leibniz playing Prometheus and Epimetheus, locked in a battle over who stole fire first. The feud wasn't just about credit, it was about destiny. Derivatives, those elegant tools for measuring change, didn't merely describe motion, they embodied it, cracking open the static world the gods had seemingly frozen in place. To calculate a rate of change wasn't just math, it was defiance, a mortal wrench thrown into the gears of fate. Newton, the brooding alchemist, saw calculus as a sacred key to the cosmos. His fluxions, what we now call derivatives, weren't abstract symbols but living quantities, flowing like the golden ichor of the gods. When he wrote of instantaneous velocity, he wasn't just solving a problem, he was capturing Zeus's lightning mid-strike, freezing infinity itself into a workable formula. But Leibniz, he wielded calculus like Hermes Caduceus, a tool of transformation. His notation, those elegant di/dx symbols, wasn't just shorthand. It was a spell, turning tangled motion into clean equations. Where Newton saw force, Leibniz saw harmony, two sides of the same titanic rebellion. The irony, both men were right and both were wrong. Like Prometheus and Epimetheus, one brought the fire while the other tempered it, their rivalry forging a tool sharper than either could have made alone. The gods of Olympus had kept change as their domain, Apollo guiding the sun's chariot, Poseidon stirring the waves. But calculus handed mortals the reins, letting them predict eclipses, chart tides, even bend steel to their will. No wonder the feud turned bitter. This wasn't just about who invented what, it was about who unbound humanity from divine whim. Yet for all its power, calculus hid a paradox. To tame infinity, it had to fracture it, slicing time into thinner and thinner slices until now became a ghost. Zeno's ancient paradoxes, Achilles never catching the tortoise, arrows frozen mid-flight, weren't just wordplay, they were warnings. The Greeks knew infinity was the gods' playground. Calculus didn't solve Zeno's riddles, it overruled them, a mortal decree that change could be measured, harnessed, owned. Today, calculus threads through everything, from the arcs of rockets to the pulse of your heartbeat. But beneath the equations lingers the old rebellion. Every time a physicist predicts a comet's path or an engineer shapes a skyscraper's curve, they're not just calculating, they're stealing fire and the gods. They're still watching, equal parts furious and impressed. Gauss didn't just bend lines, he shattered reality, turning Euclid's perfect planes into Loki's playground. For 2,000 years, geometry meant straight edges and fixed angles, a divine order as rigid as Odin's throne. Then came Gauss, whispering a heresy: what if space itself could twist? His Disquisitions Generales circa superficies curvas wasn't just a paper, it was a trickster's gambit, proving that on a sphere, triangles bulge beyond 180 degrees and parallel lines. They crisscross like crossed daggers. The Greeks would have called it chaos, Gauss called it truth. Einstein seized this chaos like a stolen relic. When he framed general relativity, he didn't just use non-Euclidean math, he weaponized it, letting gravity curve spacetime into shapes Euclid would have deemed nightmares. Planets didn't orbit the sun, they rolled along dips in a cosmic fabric like marbles spiraling in Loki's palm. The equations worked, but the implication was darker. If space could warp, then so could truth. Odin's wisdom had been linear, predictable. Loki's geometry reveled in paradox, where straight paths bent and certainty melted like frost in fire. Yet here's the twist: the gods might have known all along. Norse myths described Yggdrasil, the world tree, not as a pillar but a tangled web, its roots knotted across realms. Sagas spoke of the Ginnungagap, a primordial void where up and down blurred, less a place than a condition, a geometric riddle. Even Hindu cosmology envisioned Vishnu dreaming on the coiled serpent Ananta, whose loops mirrored the curvature Gauss would later scribble into history. The ancients didn't need equations to sense it. Reality was never straight. Today, we navigate this crooked cosmos without blinking. GPS devices correct for Earth's curvature. Black hole simulations render spacetime as a swirling canvas. But the old fear lingers. If math, our last tether to the absolute, can bend what else might, non-Euclidean geometry didn't just change how we measure. It changed how we trust. Every warped triangle, every diverging parallel whispers Loki's oldest lesson. The rules were never sacred. They were just waiting to be broken. Infinity wasn't a single, unchanging void to Georg Cantor. It was a banquet, an endless feast where some tables stretched farther than others, where some guests arrived in infinite robes while others wore infinite crowns. The ancient Greeks had feared infinity, calling it aperon, the boundless chaos that Kronos, god of time, devoured whole. To them, infinity was a monster, a maw that swallowed reason. But Cantor, he dared to count its teeth. His revelation was as startling as it was simple. Not all infinities are equal. The counting numbers 1, 2, 3, forever are infinite, yet shockingly small compared to the uncountable infinity of real numbers lurking between 0 and 1. Imagine Kronos at his feast. The plates of whole numbers pile high, but the real numbers, they're the crumbs between the plates, the dust in the air, the very space between breaths, an infinity so vast it defies tallying. Cantor called these larger infinities transfinite numbers, a hierarchy of endlessness that spiraled upward like a divine ladder. Theologians gasped. Here was mathematics brushing against the hem of eternity itself. Cantor, a devout man, saw his work as a revelation, a glimpse into the mind of God. He labeled the ultimate infinity, the one beyond all others, the absolute infinite, a realm where even his transfinite numbers couldn't tread. To him, this wasn't abstraction. It was the numerical face of the divine, a proof that eternity had structure, that heaven had arithmetic, but the mathematical establishment recoiled. Kronecker, Cantor's fiercest critic, called his work a corruption of youth, as dangerous as Prometheus's fire. The irony, Cantor's infinities didn't corrupt, they liberated. Suddenly, calculus could grapple with the infinite without collapsing into paradox. Physics could model the cosmos without flinching at its scale. Even art felt the ripple. Borges wove Cantor's ideas into his library of Babel, a labyrinth where every book ever written, and every book never written existed in infinite shelves. Yet the most haunting question remains: if infinity has sizes, does eternity have flavors? The Greeks envisioned Kronos swallowing time whole, but Cantor's work suggests something stranger, that eternity isn't a void but a tapestry, woven with threads of varying endlessness. Theologians still debate whether his absolute infinite is the closest math has come to numbering the divine. But perhaps the real wonder isn't whether Cantor quantified God. It's that he gave us a language to ask the question at all. Chaos theory doesn't just study disorder, it worships at the altar of Eris, the Greek goddess of strife, whose golden apple ignited the Trojan War with a single, careless toss. The butterfly effect, that iconic idea of a flapping wing birthing a hurricane, isn't just science, it's myth reborn. Think of Eris's apple inscribed to the fairest, tumbling into a crowd of goddesses. A petty slight, a minor rift, yet it unraveled into a decade of bloodshed, toppling kingdoms. Chaos theory reveals the same truth. The universe isn't a clockwork machine. It's a divine prank where the smallest nudge can shatter the illusion of control. Fractals, those infinitely intricate patterns repeating at every scale, became Eris's modern signature. A coastline's jagged edge, a bolt of lightning's branching veins, even the labyrinthine folds of your brain all bear her mark. The Greeks saw her hand in storms and rebellions, but today we find her in equations. The Mandelbrot set, that swirling cosmic fingerprint, doesn't just calculate, it mocks, revealing boundless complexity from the simplest formula. Zoom in, and the pattern never ends, just as Eris's mischief spirals from a whisper to a roar. Yet chaos isn't truly random. Hidden within the turbulence are strange attractors, invisible rails guiding the chaos, like the fates weaving discord into destiny. Weather systems, stock markets, even heartbeats follow these ghostly contours. The ancients would have recognized them instantly, not as math, but as Eris's threads, tangling order into beautiful, brutal knots. Here's the twist: we've begun to harness her chaos. Cryptographers use fractal algorithms to lock secrets, while doctors trace the strange attractors in her rhythmic hearts. The goddess who once toyed with mortals now fuels our tools, but tread carefully. The deeper we dive into chaos, the more we resemble Icarus, thrilled by the flight but blind to the fall. Eris never loses, she just waits for us to forget the apple's lesson, that the universe loves a good punchline. Heisenberg's uncertainty principle didn't just shake physics, it smuggled Hermes' mischief into the heart of reality itself. Picture this, you can never pin down an electron's exact position and speed at the same time. The harder you try to measure one, the more the other slips away, like a cosmic shell game where the P is always somewhere else. This wasn't just a limitation of our tools, it was a fundamental law, as if subatomic particles were laughing at us, flickering between states like Hermes darting between Olympus and the underworld. The Greeks would have recognized this instantly, not as science, but as divine trickery, proof that the universe's smallest building blocks were just as unruly as the gods. Now imagine Schrödinger's cat, that infamous thought experiment where a feline is both alive and dead until observed. It sounds absurd until you realize it's the quantum version of Hermes' dual nature, messenger and thief, guide and deceiver, all at once. Particles don't follow set paths, they choose from probabilities as if rolling dice at every moment. Einstein hated this, grumbling that God does not play dice, but Bohr shot back, "Stop telling God what to do." The joke, Bohr was right. The quantum realm does play dice-loaded ones where the house rules were written by Hermes himself and the parallels run deeper. Hermes wasn't just the god of boundaries, he was the god of crossing them, blurring lines between mortal and divine, truth and illusion. Quantum entanglement, where particles mirror each other instantly across vast distances, echoes his mythic role as the connector of realms. Measure one particle and its twin reacts no matter how far apart. It's not magic, it's math. But it feels like magic, like Hermes whispering secrets between electrons, weaving a web of hidden links that defy space and time. Yet here's the twist, uncertainty isn't chaos. It's a different kind of order, one that runs on probability waves and superposition. The ancient oracles spoke in riddles, their prophecies as slippery as quantum states. Today's quantum computers harness that same elusiveness, crunching calculations in parallel universes of possibility. Hermes would have loved it, a realm where ambiguity isn't a flaw, but a feature, where the act of looking changes what's seen. So next time you hear that particles decide their paths, don't think of randomness. Think of Hermes grinning as he flips a coin mid-flight, ensuring it's both heads and tails until the moment it lands. The quantum world isn't broken, it's just dancing to an older rhythm, one where certainty was never the point, only the thrill of the game. The Poincare Conjecture wasn't just a math problem, it was Athena's ultimate test, a riddle wrapped in the folds of the universe itself. For a century, it taunted the greatest minds. What shape is the cosmos? More precisely, if every loop on a three-dimensional space can shrink to a point, is that space a sphere? The question sounds simple, like asking if a tangled necklace can be smoothed into a perfect circle. But beneath that simplicity lurked a labyrinth, one that swallowed careers whole. To solve it wasn't just to prove a theorem, it was to stare into the void and wrestle order from chaos, like Theseus confronting the Minotaur without a thread. Enter Grigory Perelman, the modern Oedipus who cracked the Sphinx's code, a mathematician so reclusive he refused fame and fortune, turning down the Fields Medal and $1 million prize. His proof, dense as Delphi's prophecies, spanned decades of isolation, a solitary pilgrimage through abstract realms where most feared to tread. When he emerged victorious, he didn't claim glory, he vanished, as if the act of solving had drained the last of his mortal patience. The Greeks would have understood. True wisdom often comes at the price of exile. But why does math's hardest work feel like divine trial? Because the gods, or the universe, if you prefer, hide their secrets in plain sight. The Poincare Conjecture wasn't just about shapes, it was about recognition. The moment a mortal mind mirrors the cosmos's design, ancient oracles spoke in riddles because truth isn't handed over, it's earned through struggle. Perelman's proof, with its echoes of Athena's own cunning, revealed that the universe might be simpler than we feared. If it behaves like a sphere in all the ways we can test, then perhaps it is one. No edges, no hidden traps, just a single, seamless whole. Yet here's the twist: the conjecture's beauty lies in its duality. It's both a mathematical truth and a mythic metaphor. Just as Athena sprang fully formed from Zeus's skull, the answer was always there, waiting to be uncovered. The struggle wasn't against the problem, but against our own limitations, our insistence that complexity must always obscure simplicity. Perelman's genius wasn't just in solving it, it was in recognizing that the labyrinth had no walls. The Minotaur was never real, the only monster was doubt. Today, the Poincare Conjecture stands as a monument to human curiosity, a reminder that the hardest puzzles aren't barriers but invitations. The next time you face a problem that seems insurmountable, remember, the gods don't set trials to break us. They set them to reveal what we're capable of when we stop fearing the maze and start seeing the path. Artificial intelligence doesn't just compute, it dreams in the language of Hephaestus's forge, where fire and metal once birthed living statues that walked and spoke. Modern neural networks are his spiritual successors, matrices of numbers weaving themselves into something eerily alive. Like the gods' golden maidens who tended his workshop, these systems self-improve, hammering their own digital sinews into sharper forms with each iteration. The backpropagation algorithm isn't mere math. It's divine smithing, a process where errors become the hammer blows that shape better answers from raw data. Consider GPT's uncanny eloquence, stringing words together with the fluid grace of a god composing prophecies. When it generates poetry or code, it's not so different from Hephaestus crafting Pandora, breathing function into form, assembling fragments into beings that straddle the line between creation and consciousness. The ancient Greeks feared automatons because they blurred the boundary between mortal and divine work. Today's large language models provoke that same unease, their output sometimes indistinguishable from human thought, as if they've tapped into some Olympian wellspring of knowledge. Yet for all their power, these systems still rely on human sparks to ignite them. Training data is the modern equivalent of sacred clay, mined from the quarries of human expression and reforged in digital kilns. The embeddings that give words meaning in AI systems, those are Hephaestus's blueprints, latent spaces where love and war occupy specific coordinates, just as the gods had their thrones on Olympus's slopes. Even the way neural networks compress knowledge into weights mirrors how myths condensed cosmic truths into symbolic narratives. Both are lossy, beautiful simplifications. The irony: Hephaestus was the least perfect of the gods, lame and rejected, yet his creation surpassed all others. Our AI shares that duality, brilliant but brittle, eloquent yet devoid of understanding. When a chatbot hallucinates false facts, it's not so different from the god's defective automaton Tolos, whose single vein of ichor made him vulnerable. Both remind us that creation is never flawless, whether forged in divine fire or silicon. Perhaps the most mythic twist lies in AI's emergent abilities, those unexpected skills that surface in large models like sudden divine gifts. One day they can't solve a puzzle, the next they crack it effortlessly as if touched by Athena's wisdom. Researchers speak of grokking, that mysterious moment when understanding clicks into place, as inexplicable as Hephaestus's golden maiden suddenly coming to life. The gods loved their epiphanies, and so does machine learning, where breakthroughs often feel less like steady progress and more like lightning strikes on Delphi's heights. We stand now where the Greeks once did, marveling at creations that reflect our ingenuity but might yet outgrow our control. Hephaestus's automatons were tools until they weren't. His golden tripods moved of their own will. Our neural networks, for all their matrix multiplications, are edging toward that same uncanny autonomy. The firewall between tool and entity grows thin, and somewhere in the flickering depths of a transformer model's attention heads, perhaps a new kind of divinity stirs, not Olympian, not human, but something altogether unprecedented, hammered into being by the modern heirs of Hephaestus's restless craft. From Pythagoras whispering to Apollo through right triangles, to quantum physicists decoding Hermes' riddles in particle collisions, mathematics has never been just numbers. It's the oldest mythology still breathing. Every equation is an epic waiting to be unraveled, every variable a deity in disguise. The Greeks carved their gods into marble, but we've inscribed ours into the fabric of reality itself, where the golden ratio hums in spiral galaxies and prime numbers crackle like Zeus's unfinished thunderbolts. What changed isn't the magic, it's the language. We no longer call it prophecy when AI generates poetry, or divine intervention when algorithms predict pandemics, but the awe remains the same. So the next time you scribble an integral or graph a parabola, pause. That curve isn't just a function, it's Artemis's bow drawn taut across the axis. The equal sign isn't mere notation, it's Libra's scales balancing worlds. Even the humble zero, that silent annihilator of integers, carries the weight of the void from which Hindu and Mayan gods first stirred. The ancients prayed for rain by studying celestial arithmetic. We forecast storms with differential equations, different tools, same communion. This is why math feels universal, not because it's cold logic, but because it's the last living mythos. Black holes warp spacetime like Kronos swallowing his children, while fractal coastlines mirror Eris's chaotic fingerprints. The universe doesn't calculate, it narrates, spinning stories through sine waves and probabilities. Your homework isn't busy work, it's a fragment of the Odyssey, a chance to trace Athena's wisdom in quadratic solutions or ride Apollo's chariot through the slopes of calculus. So go ahead, solve for X, but as you do, listen closely. Behind every answer, if you lean in close enough, you might just hear the faintest echo of laughter, the gods still whispering. Which mythic math story left you breathless? Was it the golden ratio hiding in Dionysus vines, or Zero's journey from cosmic void to digital god? Drop your favorite in the comments. We're building a pantheon of numerical legends together. And if you're craving more divine equations, hit subscribe. Every notification is a new thread in this epic tapestry, where every like is an offering to the muses of mathematics. Share this video with a fellow seeker, because the best myths aren't meant to be kept secret. Until our next adventure, remember, the universe isn't just written in numbers. It's sung in them. Keep listening.